less than 10 seconds.
Hey everyone, Michael here from the MacMillan Space Centre. Happy Halloween! We are here with our astronomer Rachel, who is going to count down her top 10 scariest things in the universe. I can't wait. How's your Halloween planning going so far, Rachel?
Pretty good. I'm going to carve a pumpkin. I'm trying to decide what space thing I want to carve. That isn't too hard.
Well, maybe something in your list can inform you as to
Maybe.
what you're going to carve. So yeah, so let's go through your list.
Sure. And I must say that it was hard to narrow it down to 10 because there are a lot of pretty spooky things happening in our universe, but I thought I would start local. So the first one that I have is Jupiter's Great Red Spot. And it's scary to me because it's such a massive storm. It's so massive, you could fit multiple Earths inside of it. And it's also getting darker, more red in color, which I just think is a more ominous color that it's becoming from an orange to a deeper red. And even though it is shrinking a little bit, it's getting smaller, I'm still a little bit afraid of this massive storm.
So is it getting less scary then as it's getting a little bit smaller?
It's not so much less scary as more circular and just a different shape.
Yeah, that reminds me of a scene in 2010, the sequel to 2001, when big dark spots appeared on Jupiter, and that was because, you know, there was these interdimensional beings that sort of were sort of like transforming Jupiter. But you know, yeah, certainly like a big red spot. It's weird because I think it stands out because there's no other world that we have seen so far that has a shape like that. So I think scary things are usually things that are kind of like our brain can't process them because we can't compare them to something else.
And it almost looks like a giant eyeball that's looking at us. So that really adds to the scariness factor.
or winking because it's just one, right?
It's true, true. That's a nicer way
All
to
right.
look at it.
All right, let's go to number 2.
So I thought I would share my favorite exoplanet. And it's my favorite exoplanet because NASA has nicknamed it Reigns of Terror. And it's a really cool planet. It has a really long name, so I wrote it down. It's called HD 189733b. Okay.
No, that doesn't sound so scary.
Oh, but wait till I tell you exactly what's going on the surface.
Okay.
So from far away, it's 65 light years away from us, but from far away, if you were like an alien approaching it in a spacecraft, it would look a little bit like Earth. It's very blue, looks quite nice, could be oceans or something. But then you get closer, and then that's when you start to realize that it has terrible weather, worse than Vancouver. So it has these silicate particles in the atmosphere. Because it's such a hot planet, those silicate particles get warmed up and formed into glass. But not only that, the wind speeds on this planet are around 7 times the speed of sound. So that's 2 kilometers per second. And that means that all these silicate particles that formed in the atmosphere got heated up into glass are now shards of glass that are spinning around the planet really, really quickly. Hence the name that NASA gave it.
Oh my goodness. So this does sort of remind me of like a classic horror trope when maybe from afar you see like, you know, look at a nice little girl maybe playing in the playground, and then like Earth, you know, like, oh, there's Earth, I recognize Earth. But then as you get closer to it, you're like, oh, that's not a little girl, that's some demon or something.
Yeah, I gotta back away.
Wow, glass storms. That is truly horrific, Rachel. Let's go on to number 3.
Sure. And that is the fastest known spinning pulsar. So this one also has a really long name, so I won't share it, but it rotates 716 times a second. So just to remind you what a pulsar is, it's like the core of a massive star that exploded in a supernova, and it leaves behind a stellar remnant or a neutron star most often, and it has the mass of around like 500,000 Earths crushed into the size of a ball that's around the size of UBC campus. And it has these rotating magnetic fields that power beams of radiation. So that's often in the higher energy, so X-ray and gamma rays that sweep by us. And it kind of looks like a lighthouse. So like blips of light or blips of these streams of radiation passing by our Earth. And it was actually discovered in McGill in 2004. So I thought that was kind of cool, kind of a local discovery. But what's crazy is that it's spinning so fast. So theorists have calculated what the maximum rotation speed has to be before the neutron star will just rotate itself apart. And that was 72,000 rotations per minute. And this pulsar is rotating at 43,000 rotations per minute. So that's only around 60% of that theoretical threshold that they put. So what's scary to me is either we don't have the technology to detect the faster spinning pulsars, or they just don't rotate any faster. And I'm kind of thinking that it's the first one, that we just can't see them quite yet.
So this is kind of, yeah, so this is kind of like a strobe light. So I can picture that maybe this is like a spooky disco strobe light out there. Maybe we can get like the Pointer Sisters and have the
I've got the Monster
dance.
Mash now playing in my head.
Yeah, so this is sort of like a lighthouse in the fog. Is that how you're sort of picturing this?
Yeah, except that it's rotating so fast, and it's decently far away, but we're still able to pick up those beams of radiation. So that kind of spooks me a little bit.
Okay, let's move on to number 4.
Sure. Speaking of compact objects, I thought I would talk about the black hole that's in the center of our Milky Way galaxy, and that's called Sagittarius A star. So it's quite a large black hole. It's a supermassive black hole. It's around the mass of like a few million suns, so it's quite heavy. And although we know that there are supermassive black holes at the center of virtually all large galaxies, like our Milky Way, black holes are still scary objects, because even though they don't suck in material like a vacuum cleaner, they're more like a gravitational anchor. If you pass the point of no return, which is the event horizon, you will experience spaghettification. And I know it sounds like spaghetti and everyone loves spaghetti, but this is much worse. So this is the tidal forces of this black hole, that immense gravitational field pulling at your feet stronger than it's pulling at your head. So you end up getting stretched out into a long spaghetti noodle. So not as fun as spaghetti and meatballs.
Okay, that is truly terrifying. It's almost torturous, actually. You know, in the medieval days, you know, they would torture people by stretching them really far. Yeah, I can picture you being spaghettified in some sort of dark dungeon.
And you know what's cool is that because of general relativity and time dilation, if you were watching me go into this black hole, it would take an infinite amount of time for you to see me actually enter the black hole because of time dilation. And I would have been long gone by then. But the light or the info coming from my spaghettified body would still actually reach you. So it would look like I was just continually getting spaghettified and falling into this black hole.
Yeah, no, that is truly spooky right there. Like all of a sudden, like it seems like you're moving, you're just sort of like just frozen there in time, forever to be stretched to infinity. All right, let's move on to number 5.
This is gamma ray bursts, or GRBs. And what these are short bursts of gamma ray light. And so as a reminder, gamma rays are the most energetic form of electromagnetic radiation, or light, that we have. And so these can last anywhere from a few milliseconds to minutes, and they are hundreds of times brighter than a typical supernova and 1,000,000 trillion times brighter than the sun. But not only that, a typical GRB burst releases as much energy in a few seconds as the sun will release over the course of its 10 billion year long lifetime. So it's in these few seconds that we get so much energy going off. And I think that's kind of, you know, it's a little scary in the fact that we only have like theories as to where these come from, and we're still looking to test those theories. So we have ideas for sources like supernova or neutron star or black hole mergers. And the idea that if a gamma ray burst happened close to Earth, we would feel the long-term effects of it. And, you know, I quite like my time here on Earth.
Well, what exactly would happen? Like, I think the Incredible Hulk turned into a big green monster when he got some gamma rays, but what would happen to the Earth if this happened?
Yeah, so if we had a GRB close to us, the biggest effect that we would have is an increase in ultraviolet radiation. How that happens is that the gamma rays interact with molecules in the atmosphere, I believe it's nitrogen, and oxygen that it reacts with, and it forms nitrogen dioxide. And what nitrogen dioxide does is it breaks down our ozone. And we need our ozone and our atmosphere to protect us from high energy rays like X-rays and gamma rays. So because it's thinning, now we get more exposure to ultraviolet radiation coming from our sun. So it's like a really, really hot day at the beach for a long time.
So this is sort of like a form of a death ray, maybe like a Death Star coming to blow up the Earth, or maybe it wouldn't blow it up, but as you say, it would slowly erode the Earth and heat it up.
It's a slow death ray.
All right, let's move on to number 6.
Alrighty, this one is galactic cannibalism. And I thought this was kind of fitting because cannibalism is kind of spooky, but also because it's going to happen to our own Milky Way galaxy. So we know that we're on a collision course with the Andromeda galaxy, our sister galaxy that's nearby. And what's funny is that the Andromeda galaxy actually has a history of galactic cannibalism. We think that around 2 billion years ago, it already devoured another galaxy, and perhaps we are next. So that's something to be on the lookout for in the next few billion years.
Now, how exactly does a galaxy devour another galaxy?
Yeah, so it's mostly through gravity, and it's kind of weird to think about because I actually ran simulations for this in like my first year astronomy course where I collided different shaped galaxies together. And what was interesting is that if you imagine a galaxy, right, if you're looking from far away, it looks like it is pretty dense. It has a lot of stuff. But when you really look at it, the things in between are so spread out. And so when you have stars passing through one another, they're really interacting through gravity and not actually physically smashing into one another. So the gravity is kind of clumping these two galaxies together, forming an irregularly shaped galaxy.
So it's kind of like Frankenstein, like these two galaxies coming together to kind of like form like this new super galaxy. We'd have to come up with a new name for it, maybe like the Milky Andromeda, the Andromeda Way, or something like that.
We have a few billion years to come up with a better name.
All right, let's move on to number 7.
And so this one's quite fitting. So these are zombie stars. And these are really interesting because if you think about a star that's near the end of its lifetime, it's going to undergo a type 1a supernova. And that's when you have a white dwarf star who is eating and taking material from a companion star. And it undergoes a supernova once it reaches some critical mass and it can't support against the crushing pressure of gravity anymore. So it gets crushed and then ends up exploding in a supernova. But instead of ejecting all of that material, all that white dwarf material out into space, like we normally expect, this zombie star, this white dwarf star, still survives and is left there, and only half or around half of the white dwarf material is lost. And over time, if we look at this leftover zombie star, as it cools, we actually won't be able to distinguish it from a normal, regular, typical white dwarf star. So it really is coming back to life.
Now, with these, there are different categories of zombie stars. Like, are there the fast zombies, the slow zombies?
I think that because it's such a weird concept, and kind of a new concept, I couldn't tell you if there are different ones, but I'm sure that there are some sort of combination of, really fast spinning, fast spinning zombie stars, mega zombie stars, something like that.
Yeah, and they're just like slowly over time saying birds. Let's move on to number 8.
And so this has to do with the structure of our galaxy and the cosmic web. And I've pointed this out before, but in between the cosmic webs, or in between the filaments, are cosmic voids. And this is scary to me because this really is true emptiness. In some places in these voids, you have a density of less than one hydrogen atom per cubic meter. So it's really, really empty. There's nothing there. And not only do you have cosmic voids, but you can also have cosmic supervoids that are around 10 to 100 megaparsecs in diameter. And 1 parsec is something like 3 times, I want to say like 10 to the 22 meters or something like that. So something really, really large. And it's just so empty.
So just like a big black void, which is a lot of space anyway, right? Like, I think, like, if we think about the true things that we find scary, it is the dark, the unknown. What really is in there could actually be what's scary, but our brains are just going to make up something even scarier.
Right, because like when you're floating up in space on the International Space Station, at least you can see the Earth and you can see home. But
Right.
in these voids, it's just darkness.
Oh, wow. Yeah, okay, that truly is scary. Let's move on to number 9.
So if you were scared by that, Michael, this is going to be worse. So this one, so this is about the ultimate fate of our universe, and that is the projected heat death of the universe. And what that means is because we know that we're undergoing an accelerated expansion of the fabric of space-time, so our universe is getting bigger and bigger, and faster it's getting bigger. And so based on our predictions, we think that this will result in things being so far apart that not even light is fast enough to traverse the distances between them. So we won't have any stars in our skies, no galaxies, everything will be way too far apart. And so this I know this is really far into the future. Our universe has been alive for quite a long time, billions of years, and this is far off. But the idea that you could have things so even more spread out than they are now and not being able to see the stars in the nighttime sky is I don't know, kind of a scary, saddening thought for me.
So why is it called the heat death? If everything's moving apart, wouldn't things get actually really cold then?
Right. So when it's talking about heat death, it's really talking about differences in energy, differences in temperature. So not really that the temperature of the universe goes towards zero. It's more so that there are no temperature differences for any forms of work using that temperature difference. So being able to use the energy from temperature differences to do something. And so that is why it's called the heat death of the universe, so that everything kind of almost freezes.
Okay, so this is basically the fate that everyone living in Edmonton sort of has to deal with. Maybe if you lived in Edmonton, you'd be prepared for the end of the universe. All right, let's finish this off. Our top 10 scary things in the universe, number 10.
Number 10, I picked something which is outside of the universe, actually, or outside our observable universe, at least. And I picked the unobservable universe. And the reason I picked that is because, we have this boundary, this almost kind of sphere of things that we can potentially see. And that's because light has traveled over billions of years to reach us. And that radius that light has traveled defines what we can see, the observable universe. But then outside of that, where light hasn't had enough time to travel to us, we have no idea what's out there. And that's where theories like multiverse theory or bubble theory arise, because, we have no way of testing it. So there could be other multiple universes out there. But for me, the unobservable universe really strikes me as like the fear of the unknown.
Yeah, I'm thinking about like how in the planetarium, Rachel, like when you're taking us to the CMB, and then in our program, it's because it's a computer, we can actually go beyond that CMB, but then there's nothing out there. It's just a blank void. But really, perhaps and perhaps this goes for all of the top 10, that all of these scary things are actually also really exciting and cool things to think about and to learn more about, because they're scary because we know a little bit of information from them, but not a lot, which means we got to go and study them some more.
Exactly, and the great sources of information, as long as they stay a few thousand light years away from us.
Right. So thank you so much for checking out this video. Of course, we'll put some links to some of the things that Rachel has talked about. You can look into the description of this video for some of those links. And of course, like and subscribe. Go to our website, spacecenter.ca, for more information. See you next time.